Okay, so this is the second problem then in the acceleration 1-3 discussion. An automobile is moving to the right along a straight highway, which we choose to be the positive x-axis. The driver then steps on the brakes. If the initial velocity is v0 equals 15 meters per second, and it takes 5 seconds to slow down to a stop, what was the car's average acceleration? Okay, a couple of points. We need to begin to make sure that we understand the idea that in physics, the word acceleration does not necessarily mean that the car is speeding up. Acceleration simply means that the motion is changing. It could be slowing down as well. It's just acceleration is just a term that means change of motion. Okay. Now, in more modern times, obviously, it's come to mean speeding up. But in physics, it doesn't have to be. It could be slowing down as well. But we also give a special term to the motion of slowing down, and that is called deceleration. And we'll find out that we're going to have to make a distinction between that and negative acceleration. Negative acceleration is not the same thing as deceleration. Negative acceleration is acceleration that is in the negative direction. Okay, so we'll work all of this out as we go through some of these next few problems here. But let's work our way through this one then and see what we mean by what we're talking about so far. Okay, so an automobile is moving to the right along a straight highway, which we choose to be the positive x-axis. So always, 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 we're going to start our problems with our motion diagram. Oops, let's make it bigger there. And my positive x directions and my origin. Okay, and as always, we collect the same information in the exact same way every time. My initial position here is going to be 0 meters. We haven't been told otherwise, so we're free to make our statement that the initial position here is 0 meters. We are not told what the final distance is or what the final position is, so we can put a question mark there. That's a pathetic question mark, isn't it? Let's do that. Let's change that. Okay, that's not much better, is it? Okay, we're told that our initial velocity when the driver hits his brakes, v0 equals 15.0 meters per second. And we know that when we come to a stop, our velocity is 0. So our final velocity is 0 meters per second. Okay, now be aware that what we're doing with our velocity is this. Okay, so we add in our velocity vectors so we can see our motion, what the motion is represented by here. And now we need to ask the question, if the acceleration of this was in the positive direction, that would mean that the automobile would actually be speeding up. So we need to add in an acceleration that's going to cause the car to slow down. And so what we're going to say is that the acceleration here is in a negative direction. Now, the car is certainly decelerating, it's slowing down. At the same time, it's undergoing negative acceleration. Okay? And we want to find out what that negative acceleration is. So because our acceleration arrow needs to be pointing in the negative direction here to indicate that we're going to oppose the motion of the car. Okay, and that's another good way to think about it. Acceleration causing deceleration needs to oppose the motion of the car. And another thing that we can say is that the acceleration arrow always has to be going in the direction of increasing lengths of velocity vectors. Okay, so even though the velocity vectors are pointing to the right, the motion is to the right or the positive, the length of these vectors is getting longer going to the left. And it's always going to work out that if I make my acceleration arrow go in the same direction that the velocity arrows are increasing in length, I will always have the correct direction for my acceleration. Okay, so a lot of things to consider here. Okay, so let's go ahead and finish the problem then. So I can now add in my given. My given values are going to be x0 equals 0 meters. My final x I'm not aware of. I don't know what that is. My initial velocity is 15.0 meters per second. My final velocity is 0 meters per second. And I don't know what my acceleration is, but I know that I need that. And because my acceleration arrow is pointing in the negative direction, my math also has to work out so that I have a negative sign in front of the acceleration. Let's see if that happens. My formula, the only one I know for acceleration equals change of velocity over time equals final velocity, always final first, right? Final velocity minus initial velocity over time. And then I'm going to solve, and I'm anxiously going to wait to see if I get a negative value. So A equals, my final velocity is 0 meters per second. We're looking good here. Minus 15 meters per second, which was my initial velocity. And this is going to be over how many seconds? It was 5.0 seconds. And again, I forgot to put that in my given list. Shame on me. Okay, and so if I do this, my acceleration equals negative 3.0 meters per second squared. Okay, now, and we'll talk about the units here in a minute too. So 15 divided by 5 is 3, but I'm in the negative direction, so I get a negative 3 meters per second squared. And that's going to cause the car, which is going in the positive direction, to decelerate. Now, if the car was going in the negative direction, if it was going to the left, that negative acceleration would actually cause the car to speed up in the negative direction. But we'll talk more about this idea of negative acceleration versus deceleration versus positive acceleration and negative and positive velocity as we go through more of the problems here. Okay? So go ahead and close this video and go back to the regular video.